So the topic is mathematical intuition as a simple computer, and how uh, it is possible to create this account of mathematical intuition. And the uh, the the claim here is that we need some way to remove uh, a contamination from uh, we have to remove contamination. And so what we're now saying here is that we're going to describe the way mathematics really works. And that is by making observations, by formulating observation axioms, and then by formulating explicit definitions in terms of set theory, such that those observation axioms are entailed by the axioms of set theory, using the inference rules of first-order logic. What you can then do is you can forget the set theory axioms. You can treat the set theory axioms as contamination from the point of view of finding proofs. And this isn't 100% correct, but the thinking here is that there is some problem-solving apparatus of the brain or the mind that does not make reference to set theory, that rather makes reference to lists of axioms. In a sense, it works much closer to the Chapter 4 query language than it does to the axioms of set theory. And rather that set theory is in fact raw data for this query system. But however, it's also raw data that can contaminate a calculation by causing the calculation to take too long or get lost in some, basically some inefficiency. Basically, the issue here is that the thinking here is that there exists, in mathematical intuition, is essentially the Chapter 4 query logic. If you feed it your observation axioms plus your set theory axioms, then it'll just gum up the system. It'll take forever to run. And by forever, I don't mean literally forever. I mean something like, billions of years. If you give it just the observation axioms, then it quickly produces everything you want to know. It quickly resolves questions regarding the observations because you didn't contaminate it with the axioms of set theory. So the trick of mathematics is really decontamination in order to create a process that resolves and finds a outcome in a reasonable period of time, which is usually like a split second or something, or maybe whatever, But it feels like nothing. It feels like almost like it's just sort of there. It's present. It's obvious. This is why mathematicians keep using the word obvious, I think, but whatever, that's a digression. So, this is the account, this is sort of now mathematical criticism. This is sort of a philosophical account of mathematical intuition. And what we're doing now is we're saying that the sort of this there's this critical process of decontamination. We're claiming that the reason why this decontamination is important is because it purges the um, the system of anything that would slow down a specific calculation, which is this. What we're going to, maybe we will, maybe we won't claim that this is essentially a unification algorithm that the brain is doing. That we're basically there's this. It's straight up unification. That's all it is. That's what this mathematical intuition is. With maybe there's some tweaks, maybe there aren't. I mean, who knows? But it's like it's a little bit. We're now getting into the realm of making claims that may not be 100% true, but are more in a sense of intended to be kind of the trail, okay, and that provide clues. So the mathematical intuition is then the account is that it is this query language, it is a query system. In order to get reasonable responses, we need to clean the inputs. And what the mathematician does is essentially walking from the set of set theory axioms to the set of observation axioms. Okay. And sort of the claim is that there is this mental walking that goes on that verifies that the observation axioms can be entailed, given an explicit definition, by the ZFC axioms. Once that is done, the mind then has a sort of a way of answering questions. There's a way of sort of seeing what is true in the observations. And sort of this is now the process of extrapolating the observations into, sort of a kind of a way of generating observations through the observation axioms. Okay. So now we have this way of seeing what is true in the observation axiom world, and then we go back and then we use set theory to prove things about this observation world, and it's really this sort of, I don't know how to put it. It's generated observations. So there's this sort of, I guess I'm sort of going off, but into something else. But the question is, there isn't really a question, but the claim is that this is what the mathematician does, is that there's this is how we validate, in a sense, the observation axioms, is by connecting them to the set theory axioms through explicit definitions. And this, what we do is we then say, the thinking here is that this means that we can connect the observation axioms to ZFC set theory. And we can then, I think what this means then is then we can say that the consistency of ZFC set theory implies the consistency of the observation axioms. And this is really what we want. This is what we take as, I guess, the credential, or the kind of the ticket that we have to purchase in order to sort of legitimately study the observations and the observation axioms as legitimate mathematical objects. That is to say, we can be, a legitimate patron or whatever.